Hello everyone. This lecture is exclusively recorded for first year student of BK Birla College, Kalyan. In this lecture, we will prove the Hausdorff property of real numbers. So let me write down what is Hausdorff property. The Hausdorff property says that if we have two real number, if P comma Q are two real number such that P is not equal to Q, that means they are distinct, then there exist disjoint neighborhood of P and Q. So if you draw a neighborhood around P and neighborhood around Q, then their intersection is disjoint. So there must exist a disjoint neighborhood. So existence of disjoint neighborhood, it says. The property can be written in other way, or the same property can be written in another way if P comma Q are real number such that P not equal to Q, then there exists R greater than 0 such that neighborhood of P with radius R intersection neighborhood of Q with radius R is equal to empty. When I say empty, that means the intersection is disjoint. Well, to prove this theorem, I need to recall some prerequisites. That is nothing but neighborhood. So let's recall what is meaning of NPR. So the definition of NPR is nothing but set of all x belongs to R such that the distance between x and P is less than R. And we have already seen that when this is same as basically P minus R comma P plus R. So if I say y belongs to NPR, which is equal to P minus R comma P plus R, that means y belongs to in between P minus R and P plus R. So this would imply P minus, I will say right, y lies between P minus R to P plus R, because y belongs to P minus R comma P plus R. This is same as minus R less than y minus P less than R. That would imply modulus y minus P is less than R. So these all are if and only if. So what we have shown that if y belongs to NPR, this means the distance between y and p is less than r. Right? This all everything we have done already, or maybe these all are the results which we have used or we have proved already. These are the properties of modulus function. So this much information is enough to prove the Hausdorff property. So now let me prove the Hausdorff property. So proof of Hausdorff property. Hausdorff property says that if P and Q are distinct real number, then show that their intersection is empty. So we have to prove that. That is to prove that NPR intersection NQR is equal to empty. This is what we have to prove. So the proof is by method of contradiction. So we assume that suppose it is not empty. So let it possible NPR intersection with NQR is not equal to empty. So if it is not equal to empty, that means there exists an element which is present in NPR as well as NQR. That would imply there exists an element X such that X belongs to NPR as well as X belongs to NQR. So X belongs to both neighborhoods. So when X belongs to NPR, that means the distance between X and P is less than R. Similarly, when X belongs to NQR, that means the distance between X and Q is less than R. That would imply the distance between X and P is less than R, and the distance between X and Q is less than R. So, number one, I will okay. So now what I'll say, consider modulus of P minus Q. So I will add and subtract X. So that means I have added 0. So it will not affect anything on the mod P minus Q. So now I will use the triangle inequality on these two numbers. So which is less than equal to mod of P minus X plus mod of X minus Q by triangle inequality. But mod P minus X is same as mod X minus P plus mod X minus Q. The reason is modulus of minus A is same as mod A. So modulus of negative number is same as itself. So if you take minus sign outside this, then you will get minus of bracket X minus P. But minus of mod is same as that number itself. Now I can use the number 1. So but X minus P is less than R, X minus Q is less than R. So I will have R plus R, so which is 2R. So what I got is as follows: mod of P minus Q is less than 2r. But r is a positive real number. So if I take r is equal to, now mod p minus q divided by 2. Now this is strictly greater than 0. The reason is we know that p is not equal to q. That means p minus q is not equal to 0. And if p minus q is not equal to 0, then modulus of p minus q is greater than equal to 0 hota hai. Mod of any number is greater than equal to 0. But p minus q cannot be 0. So that means p minus q, mod of p minus q is strictly greater than 0. When mod of p minus q is strictly greater than 0, that would imply mod of p minus q divided by 2 is also strictly greater than 0. So this r is greater than 0. So if I substitute r over here, so p is fixed, q is fixed, mod p minus q is also fixed, divided by 2 is also fixed. So what I will get is as follows: p minus q less than 2 times mod p minus q divided by 2. So this will imply 1 is less than 1, which is contradiction. And why we got a contradiction? We got a contradiction because we assume that NPR intersection NQR is not equal to empty. So we got a contradiction because of our wrong assumption. So hence our assumption is wrong. Hence our assumption is wrong. So this would imply NPR intersection with NQR is equal to empty. That is, P and Q belongs to R such that P not equal to Q have distinct, have disjoint neighborhood. So the proof is simple. Now I just want to tell you one small remark. Now is this R spatial? Can I take some other choice of R? Yes, you may take here. If I take instead of 2, if I take 3, then what I will have? I will have in that case 1 is less than 2 by 3, which is again a contradiction because 2 by 3 is 0.666. So 1 cannot be less than 0.666. You may take instead of 3, you may have 4 also. Then I will get 1 is less than 2 by 4, which is 1 by 2, which is 0.5. So 1 is less than 0.5. So in fact, any number you have to take in a denominator which is greater than or equal to 2 will work out. If you take denominator, if you do not take anything in the denominator, then you will not get a contradiction. Then in that case, you will have 1 less than 2, which will not give you contradiction. So you should have any number which is greater than or equal to 2 in denominator. Then you will definitely have you will get a contradiction. So proof was not difficult. So let's have a quick application. So prove that pi and 22 by 7 have distinct have disjoint neighborhood. Solution. So you can see that pi and 22 by 7 are not equal. So we know that WKT stands for, we know that pi is not equal to 22 by 7. So if the two numbers are distinct, then definitely by Hausdorff property, you can show that they have disjoint neighborhood. Well, we'll prove this. Basically, we will be using the same analytics, same way of how we prove the Hausdorff property. On the same line, we will prove this. Now, many of you may wonder that is pi not equal to, why pi is not equal to 22 by 7? Because in a school you must have written pi is equal to 22 by 7 or pi is equal to 3.14. That's a common way people write it. But pi is not equal to 22 by 7. A quick justification why it is, one can justify in a following way. The justification is as follows. Pi is irrational number. Right, and 22 by 7 is rational number. So how come a rational become an irrational? So one is rational, another is irrational, so both are not equal. So one may ask that the question that, then in a school we used to write pi equal to 22 by 7. Was that a wrong calculus? Was that a wrong methodology? So answer to this, in a school or in a now onwards when you write pi, it was pi is approximately 22 by 7. It is not equal to 22 by 7. Or you may say that pi is approximately equal to 3.14 dot dot dot. But it is not equal to 22 by 7. That should be clear. Okay, so I need to prove that pi and 22 by 7 have disjoint neighborhood. So that is to prove that there exists r greater than 0 such that n pi r intersection neighborhood of 22 by 7 r is equal to empty. How to prove this? So by method of contradiction, let it possible n pi r intersection with n 22 by 7 comma r is not equal to empty. So this would imply there exists a element x belongs to n pi r and the same x also belongs to n 22 by 7 comma r. That would imply when n x belongs to n pi r, that means the distance between x and pi is less than r, and the distance between x and pi by 22 by 7 is also less than r. Number this as 1. Now I will consider modulus of pi minus 22 by 7, which is equal to, so add and subtract x minus x plus x minus 22 by 7. Now I will be using triangle inequality, pi minus x plus x minus 22 by 7. But modulus of pi minus x is same as modulus of x minus pi plus modulus of x minus 22 by 7. This is less than r and this is also less than r, so I will have 2r. So I got pi minus 22 by 7 is less than 2r. Now I can take r as mod of pi minus 22 by 7 mod complete divided by 2. So if I take that, then I will get 1 is less than 1, which is a contradiction. So why we got a contradiction? Because of our wrong assumption. Hence, our assumption was wrong. So this would imply n pi r intersection with n 22 by 7 r is equal to empty. So this completes this application. So there is a nice example for the homework. Prove that 1.5 and to have distinct disjoint neighborhood. So one can prove this on the same line. It's not at all difficult. So this Hausdorff property is one of the important property in a calculus, and we'll be using this. We will have more example based on the Hausdorff property in future. So I hope this property is very clear. So in upcoming lectures, we will also explore the concept of upper bound, lower bound, and the properties of upper bound and lower bound. Thank you.